Welcome to the chapter 2.4 through 5 lesson video. So this is going to cover chapter 2, sections 4 and 5. We're going to talk about solving triangles and some applications of it. So this is going to be a couple word problems and some vocabulary with stuff like that, as well as this one sort of longer problem. And so I would encourage you to maybe watch that part a couple times in order to really grasp what's going on there, but we'll practice it in class as well. Let's go ahead and get started. All right, so first thing we're going to talk about is when asked to solve a right triangle, you're going to set up your triangle in this form. Solving a right triangle means that your right angle is angle C and across from it is little c. I then usually draw it in this manner where capital A is this angle with across from it little a, and capital B is this top angle and across from it is little b. If you switch A and B, it's not too big. If you change the orientation of the triangle, it's not too big of a deal. As long as C is the right angle and the little letters are across from their big letter variance. All right, so if we were asked to solve this triangle, the first thing we should really do is we should draw a picture of that triangle. So if we're doing that, we're going to go ahead and we're going to draw it like this. I'm going to change the orientation just to fit a little bit better on my screen. So there's my 90-degree angle. This is big C. Across from it will be that little c, which we just found to be 12.7. All right, and then we can make any one we want, but I'm going to make this one big A, which we know is 34 degrees and 30 minutes. Now, we still have some stuff to find. That stuff that we still need to find, I'm going to put in a slightly different color so we don't forget about it. I still need to find big B over here and little b, the side across from it. And I still need to find little a, this one right here. Now, when we're solving a triangle, we basically have a couple things at our disposal. The sort of methods that we have at our disposal are SOHCAHTOA. Right, we got our trig that we can do to find our missing sides or missing angles. And then also we can use Pythagorean theorem or triangle sum, that the triangle angles have to add up to 180 degrees. We'll use whichever ones of these are most useful for us in order to find all the other missing angles. So I usually try and decide between Pythagorean and triangle sum first. In this case, they give me two of the angles, so I'm going to use triangle sum to find the other missing angle. All right, so to find the other missing angle, angle B, all right, let me make sure I'm using the right color. Angle B is going to be 180 degrees in the triangle minus the other two angles. So that's minus 90 and minus 34 degrees and 30 minutes. If I subtract these out, I will get a remaining value. B is 55 degrees and 30 minutes. All right, so I just did a little bit of that math on my side, so I didn't demonstrate it right here, but if you calculate this out, 180 minus 90 minus 34 degrees and 30 minutes, it'll leave you with 55 degrees and 30 minutes. Now, my other calculations I'm going to have to do, so that got me B, so that part is done, big B is done. I'm going to have to use some trig in order to find little a and little b. I'm probably going to use this original angle they gave me here to find A and then to find B. So I'm going to use trig. A is my opposite, B is my adjacent, so I'll probably have to use sine and cosine since they gave me the hypotenuse. So I'll set those two problems up. I'll say the sine of 34 degrees and 30 minutes is equal to my opposite side A over 12.7. All right, I'll multiply that 12.7 over, and A is going to equal 7.19. I'll go two decimal places, 7.19. That was just found by taking that 12.7 right there and multiplying it to the other side and calculating that on my calculator. All right, and then the last piece I need to find is little b. Little b is going to look really similar. It's going to be the cosine of 34 degrees and 30 minutes equal to little b over 12.7. So very similar, except now we're using cosine because b is our adjacent side here. So we'll plug that same thing, we'll plug that into our calculator now, and we get that little b is equal to 10.5 4, 7. All right, so as we're solving right triangles, I would encourage you to try these calculations on your own. Pause the video as you go if you need to. Make sure you can plug these things in your calculator. You're either going to start by using Pythagorean theorem to find a missing side of the triangle, the right triangle. That's a squared plus b squared equals c squared. You're going to use triangle sum like I did right here, 180 minus the other two angles to find the other missing angle. And then you're going to use your trig, your SOHCAHTOA, in order to find the other missing sides. All right. So when we get word problems, one thing that we might run into is we might run into this phrasing of angle of elevation or angle of depression. Now, we've talked about this a little bit one time before, but I just want to clarify for anyone that might still be confused. If I am a little person right here, normally as a person, when we look at stuff, we look straight ahead. All right, we're going to use the same example for both of the vocab words here. We normally look straight ahead at something. But say instead of looking straight ahead, I look up at the top of a tree. If I look up at the top of the tree, I've now elevated my angle of view. So this angle created between the horizontal and the diagonal is called an angle of elevation. Now, angle of depression is a little bit harder for people. Say I'm a little person right here and I'm standing on the edge of a box or something, and I decide I want to look down at something on the ground. I decide I want to look down at something on the ground. Now, a lot of times people want to make this inside angle between the vertical and the diagonal, the angle of depression, but that's not it. It's the angle change from our norm. We don't normally look straight down, we normally look straight out. So this angle right in here is our angle of depression. Now, when you're dealing with angle of depression, I think we'll do this in a practice problem in just a second. A lot of times you have to either use complementary angles to find this angle now, or since the ground is usually parallel to our line of sight, we can use alternate interior angles and match that angle down here if we finish off the triangle. So this is just a quick definition of angle of elevation and angle of depression. Let's see if we got a practice problem. Okay, so whenever we have these word problems, there's kind of three things we want to do. You'll see a couple of them. There'll be ones on the homework and the study guide. But you want to draw a picture of the scenario. You want to use the picture to create an equation with some trig values involved. And then you want to solve, and then make sure it makes sense. If you get a 5,000-foot tall tree, something probably went wrong. If you get a 2-foot tall flagpole, something probably went wrong. So make sure that your problem actually makes sense for the context that we're working in. All right, so this one says Shelley stands 123 feet from a flagpole. So we're going to draw a picture of this. So here's Shelley. We're going to make her stand 123 feet from a flagpole. So here's our flagpole. Okay, she knows the angle of elevation is 26.67 from her eyes to the top of the flagpole. So from her eyes to the top of the flagpole, so normally her eyes would look straight at the flagpole like this, is 26.67 degrees. All right, she also knows that she's 5.3 feet tall. So we know that her eyes are a little bit off the ground already. So when we're doing these calculations, we got to take into account that your eyes aren't in the dirt. Your eyes are at the top of your head, at the top of your body. So when we calculate this distance right here, we can add in her height to get the actual height of the flagpole, because that's what we want to find. We want to find the height of the flagpole. Well, we know the adjacent piece. We know this 123. We want to know this opposite piece. So this is what we're looking for right here, is this x. So opposite, adjacent, we're going to go ahead and use tangent. So we'll say the tangent of the angle 26.67 is equal to our opposite side x over our adjacent side 123. We'll plug that calculation into our calculator and get x equals 61.78 feet. So that x piece, that piece right there from the line of sight straight across to the top of the flagpole is 61.78 feet. But we asked for the full height of the flagpole. So that's not our full height of the flagpole. We need to add in her height to that as well. So if we add in her height to that as well, we get that the flagpole is about 67.08 feet tall. All right, so that's just her height plus the height of the flagpole together made 67.08 feet. All right, another type of word problem you might see is describing some sort of geometric image. And with that geometric image description, you can go ahead and do some calculations using our trig. So this says find the height of an isosceles triangle. All right, so let's draw an isosceles triangle. Isosceles triangle has two sides that are congruent. So these two sides are congruent with a base of 36 inches. So this whole base right here is 36 inches. And then the angle opposite that base is 24 inches. So it's telling us that this angle up here is 24 inches, or 24 degrees, excuse me. Now, some of you might say, oh, well, this isn't a right triangle. We can't do trig. We're kind of stuck. But the nice thing about isosceles triangles is they are symmetric. So what we're going to do is we're going to slice this triangle right down the middle. If we slice it right down the middle with an altitude, we create a right angle here, and we've now created two smaller right triangles. So let's actually just redraw just one of those right triangles and see if we can use that information. If we redraw one of those right triangles, we got to remember that we cut it in half. Right down that isosceles triangle, right down the middle. So we got to figure out the halves of stuff. So we made this right angle, half of 24 degrees. That means up in here we have 12 degrees now. And then the base was 36 whole. So now instead of 36, we actually have 18 inches down here. Okay, well, we now have enough information. What we really wanted to find all along was the altitude or the height, that line that we drew, that's the length that we want to find. And we can use trig to do that. So this is a tangent problem. We're going to say the tangent of 12 degrees equals my opposite, 18 over my adjacent x. We're going to multiply the x over and divide the tangent back over, so we get x equals 18 over the tangent of 12, and we'll go ahead and plug that into our calculator. 18 divided by the tangent of 12, and we get that x is about 84.68, and the units we were using was inches. So sometimes we'll get these scenarios where it didn't necessarily start out as a right triangle, but we could do some creative stuff in order to turn it into a right triangle so we can still use our trig. All right, we got one last problem, and this last problem is going to take us a few minutes. So if you need to take a little break here, that's totally fine. I think that's a great idea, just for a moment, because this next problem is going to take a little bit longer. And I want to warn you, you might want to watch it more than once, so make sure that you take a breath before you start in on it. All right, so I'm going to encourage you to write this problem down with me, do it with me, maybe watch it again, maybe try it again on your own. There's going to be a problem exactly like this on our upcoming test, and so I want everyone to be aware of that so everyone gets a fair shake at learning it. It's going to require you to be able to do trig, and it's going to require you to be able to do a system of equations, which is something that you might not have thought about as much recently. So what we're going to do is we're going to recognize that there are two triangles here. There's the big outer triangle with an angle of 43 degrees, and then there's this smaller inner triangle with an angle of 55 degrees. We are being asked to find this height right here. Well, in order to do that, we're going to need to add one little variable for ourselves. We're going to need to add this variable in here, x, for this unknown piece here as well. We can go ahead and we can start trying to set some stuff up now. So using our trig, we have this angle, 55 degrees. We can do the tangent of 55 degrees is equal to the h variable over the x variable. Okay, if we look at the other angle of reference, this 43-degree angle over here, we could also say that the tangent of 43 degrees is equal to h over x plus 213. So since this whole base is the adjacent side for 43, we have to add the x and the 213 together there. Well, I'm going to go ahead and do a little bit of rearranging here because I notice these both have this h in common. So if I multiply this x over and I multiply this over, I'm going to be left with h equals in both equations. So my first equation is going to become h equals x times the tangent of 55 degrees. My second equation is going to be h equals parentheses x plus 213 times the tangent of 43 degrees. All right, well, I can take that tangent of 43 and distribute it to both pieces right here. So I'm actually going to do that as well while I'm here. So I really get that h equals x tangent of 43 degrees plus 213 tangent of 43 degrees. And you might at this point be like, well, you're just doing numbers. You're just moving numbers around. Nothing's actually happening. But something really important just occurred. We have one equation equal to h. We have another equation equal to h. So if this equals h and this equals h, then there's a certain property out there called the transitive property that allows those two things to be equal to each other. Since they both equal h, we can now set them equal to each other. X tangent of 55 is equal to x tangent of 43 plus 213 tangent of 43. All right, so we now have one equation with one variable, only one variable x. If you remember back in previous courses, you probably had something similar to this. Your goal is to get all the x's on one side so you can pull them out. So we'll go ahead, we're going to subtract this x tangent of 43 over to the other side. So we get x tangent of 55 minus x tangent of 43 equals 213 tangent of 43. Since x is in both of those, we can pull it out as a common factor. X tangent of 55 minus tangent of 43 is equal to this 213 tangent 43. And then we can divide that parentheses back over to get the x by itself. So x equals 213 tangent 43 divided by the tangent of 55 minus the tangent of 43. Yay, we solved for x, but unfortunately, we didn't want to solve for x. We want to solve for this h. So what we're going to have to do now is get an estimation of this x by plugging it into our calculator very carefully. That's something I'm going to hopefully be able to talk to you guys about more in the live session, is plugging this into your calculator carefully. You plug in your calculation, and you're going to get x equals approximately 400.75. I'll go 4 decimal places, 17. Okay, so we now know that this x piece is this number approximately. And you're like, well, we didn't really want x, we actually wanted h. X was just something we made up to help ourselves. Well, if we go back to our equations over here, we have one where if we take this x value and plug it in, we can pretty easily find h now. So this is kind of just like a normal systems at this point. So we'll go h equals 400.7517 times the tangent of 55. You'll go ahead and plug that into your calculator. So times the tangent of 55, and you get that the height of that triangle, that h we started out looking for, was 572.33. I'll just go 2 decimal places, and then our units was meters. Woohoo, we did it, we found it. It looks like a lot of work when you kind of just look at it in this form, but it really wasn't that bad. We had 2 right triangles, so we did 2 tangent problems for SOHCAHTOA. We solved them both for h, and we distributed out. We set them equal to each other. We got the x's on the same side. We pulled out that x and divided it over. Plugging it into the calculator is going to be an issue for some of us. Do your best to plug it into your calculator. We'll talk about it in class a little bit, but make sure you can plug things into your calculator. You get your decimal approximation, plug it back in to get the height. You're gonna have to do a problem almost exactly like this with just slightly different degrees and a slightly different number right here on your test. So make sure it's something that you can duplicate. If you have any questions, please reach out to me, let me know. If you want to watch this again, I strongly recommend you watch it again so that way you can see it done from scratch. This is something you're going to need to practice a little bit because there is a lot of little steps along the way. I'll see you in our next live session, and in the meantime, I hope you have a great day.